Wow, I see nobody. Good. Thanks, Andy, for having me here. It's my first Brighton Ruby, so I'm super excited. I heard only good things about this conference. And I'm going to go straight to the point because I don't have a lot of time, and I have a lot of things to say. I speak a lot. I'm Spanish, so that's what it is. So I wouldn't say that I don't reuse my passwords, but I often copy and paste my own slides. So if you've seen me before, just get ready for more animations and as many emojis as I could fit on these slides. My name is Julia. I'm from Barcelona, and I've been working with Rails and Ruby since 2011. I like to give talks about like real life stories or solutions. I won't just show you like a tool and how to use it because we are developers and we know how to read documentation, right? But I want to show you a simplified version of like our real life setup at the company that I'm working for. And I love when I learn something that I can just go the next day and apply at my company and my normal job. So I hope that you will get something out of this talk. I work for Harvest, the time tracking tool. I don't know, like it's some people know it here. I've been 9 years working there. It's been built in Rails since the very beginning, since 2006. We've always had like a small engineering team, and that means that I had the chance to like touch many areas of the code base, including the ones that I'm going to talk about today. But it was not set up by me. I am just the lucky maintainer who gets to like explain to people and go to conferences and be a speaker. So thanks to my colleagues for like the work they've done. And finally, I want to say that we have an amazing security team at Harvest. And I'm not saying this because the manager, who is also my boss, is just sitting there. Give me a raise. No, I'm just kidding.
No, give her a raise.
Yes. So let's go straight to the point. So what is this talk about? When we talk about defending or securing web applications, we usually hear the same concepts, which is like cross-site scripting, cross-site request forgery, SQL injections, credential leaks, open redirects, and those matter, but this talk isn't about those. I will talk about how evil people on the internet might misuse your application and how to stop them before they cause any harm to your infrastructure, to your reputation, and your users' privacy. Also, if a bad actor is watching, sorry, you won't get anything useful from this talk apart from knowing that we see you, we know you're there, you know, and you have no chance with us. So just go away, please. Let us just do our job. So let's start with some easy definitions. So what is a bad actor? So while I was prepping this talk, I asked my manager for advice on the title. He told me there is a difference between spammers and scammers and all other kinds of people who misuse our applications. So I went for like the common term, bad actor. Sometimes they call them malicious users or whatever, like there are many definitions. So a bad actor is any human or automated system that intentionally abuses or misuses or exploits an application to gain unauthorized access, cause disruption, or commit fraud. I usually go find like a quote from somewhere, but I wanted like a definition that summarizes that a bad actor can be both humans and automated systems, and that they have different goals here. So I went to ChatGPT because we all know we are now all using ChatGPT or whatever tool of your choice. The more features you ship, the more doors you open, and the more you need to plan for creative misuse. So let's list some of these bad actors. And if you don't get something now, I need to go very quick, but then we will go into detail later. So like bad actors can be bots, they don't sleep, they love login and sign-up forms. These are automated systems behind the brute force attacks like credential stuffing or mass submitting of fake signups or crawling your website for scrapable data. They are noisy, they are fast, and usually not very smart, but they can exhaust your system infrastructure, pollute your database, and serve as a smoke screen for more targeted attacks on your customers' data. We also have the fraudsters, which might not care about your product or features, and they just like use your like billing systems to like try stolen credit card details to validate which ones are still valid, and then sell that information to somebody else. The problem is like if they slip through, the consequences land on your application, yeah, dispute fees, support overhead, or like damaged reputation. We have the scammers. They rely on deception, they exploit app features and impersonate trusted parties to trick victims into handing over information, money, or just have people calling them and they can continue with the scam. We have the spammers. Just want their message to get out. For example, if like us, you have an application that like allows to send emails to random email addresses, they are going to use that a lot. They can erode trust in your platform, have legit emails be marked as spam by email clients, and waste resources too. We have the DDoS actors that aim for maximum disruption. They don't want in, they want your application to go down. And probably you will detect them very quickly when something's like, oh, everything's broken now. Their goal is to overwhelm your infrastructure, just out of malice, extortion, or because your app just happened to be on their way and they are just like the meanest people. And these ones that I call an intentional chaos monkey, these are well-meaning users who accidentally stress test your application. So I wonder if somebody had like a user with well-intentions almost bringing down the infrastructure, because we had it, we had it, and it's like, why did they create this API integration? These people are crazy. So yeah, just to clarify, all these kinds of bad actors, they can use automations. That I call them bots doesn't mean it's just the only ones that they use automations. It means like for bots, it's more like brute force attacks, and they are high volume, fast, and dumb. It's about the technique and not whether they use automation or not. So how we do defend our applications from all of this? Because we, at Harvest, we have all of these cases. In most of my presentations, I like to explain the problem first and then jump into real-life code examples. But this time, since we are dealing with multiple kinds of abuse, and that means different techniques and tools, I'm going to dive into the tools that we have first, and then I'll show you like specific examples on how we prevent misuse from different kinds of situations that we have. So let's first explain the multiple layers an HTTP request. So we have a web app, right? So let's explain the multiple layers an HTTP request can go through. First, at the edge, we got the web application firewall. We use Cloudflare in this case. It blocks known bad IPs, bot traffic, and DDoS attacks. And we have set up some custom rules and like the default rules and so on. After that, the request goes to the load balancer that makes sure the traffic gets distributed across systems. After that, we have the reverse proxy, which is like a requirement on Ruby applications. It handles a lot of things, but it also adds another line of defense where you can like set up rules for malformed requests or sketch requests. Once we pass through that, we are like in the rack server, and here's where, like, if we are all Ruby developers, we live here. This is the layer I'm comfortable with. This is where our rack-based application, Rails, Sinatra, Roda, is processed, and all our Ruby-powered defenses kick in. And for most of us, at least for me, it's like the only thing that I really understand. Ideally, a malicious request will never reach the Ruby app. Through the life cycle of the request, there are multiple points where we can intercept malicious traffic. And the earlier we can do it, the better, because the less resources you are going to waste. But it's not always that simple. Some of these tools can be unfriendly to developers, hard to configure, and or pricey. So maybe you are not at a point that at your company you can set up Cloudflare. And most importantly, they don't have access to your business logic. So for sophisticated attacks, they cannot tell the difference between a legit user doing something weird or a bad actor trying to break in. And remember that we are trying to prevent abuse without locking like legit users out of the application. So sit back while I take you through how we stop abuse in all of those layers. No, just kidding, because Andy told me that I only have 30 minutes. And I don't have time for all of this. Also, we've got an amazing SRE team at my company that helps us handling most of at least the 3 layers, and we join forces in case there is a situation that we need to handle. What I know? What I know is what happens inside of the Ruby layer. That's where, as I said, we live, so we are going to focus on that. So we made it past the firewall, load balancer, and the reverse proxy, and now the request actually reaches our Rails application, in our case. First, before you think about fancy abuse prevention, you need to make sure your app is protected from classic vulnerabilities like the ones that I mentioned earlier. So like we are past that. Like our app is secure. We don't have SQL injections that hackers can benefit from. The good news is that Rails does a lot of the heavy lifting, so I recommend that you get familiar with that. And beyond the built-ins on Rails, we also have a lot of observability tools and custom logic to detect, investigate weird behavior. So more on that coming up. So what is the tool that we are using, mostly using to prevent misuse? The tool that we are using, it's called Rack Attack. It's a rack middleware for blocking and throttling abusive requests. So we know that what blocking means, it's just denying the request and have the user say, no, you cannot access this. But throttling means setting a speed limit on requests. If we notice a weird pattern, like a login form being hit multiple times a second by the same IP, we don't block right away. Instead, we want to slow it down for enough time to make the sketchy automation ineffective and also give us time to investigate what's going on. Throttling is one of the most effective tools we have to fight abuse because we cannot just block everything, or we will lock legitimate users. For example, a frustrated user introducing their password 5 times, which happens, right? Or somebody with a slow internet connection just refreshing the page. Rack Attack sits right in your middleware stack, which means it's executed before the Rails controller, so it's great because then you can stop the request earlier and gives us fine-grained control how our requests are allowed, denied, or throttled. It was originally built by Kickstarter. It's pretty popular. The last release is from 2023, which is but they have an active main branch, so I guess something is coming up soon. It still works pretty great, and we can use it with the latest Rails version if we want to. So just some simple examples so we understand what's coming later. This is one simple example on how to set up a throttling rule. You give it a name, you set up a limit of requests and the period, so it's 100 requests every minute, and then you return, if your block returns a truthy value, that will be used as discriminator. So in this case, we are throttling, we are allowing 900 requests every minute per IP. This is also you have access to the request, so any data you can get from the request you can use here. You can also use it for block them, you can set up a block rule with a name and then say all the requests with this user agent, if we detect a sketchy activity, we do a deploy and we just set up custom rules. By default, the usual response, so Rack Attack will execute the rule and return the the response statuses for throttle, which is 429, or block request, which is 403. But you can also customize that. So for example, I think this is very interesting because I hope you can see it's very tiny. We are using Rack Attack annotates data on the request. So we are using that to add extra logging that we can use later on our Kibana. We use Kibana for browsing the logs and searching. And we know what happened to a user, what was the rule that stopped them, so that's very useful. And then we can change the format of the response based on the accepts header. And yes, you're reading XML, and that's not dead code, unfortunately. So we still have that there. Another good thing about Rack Attack annotating the request that I wanted to mention is we also have added extra logging in all our actions. So if one endpoint on our controllers hits one of the rules, because it's annotated with Rack Attack data, we can also add information on our logging. So later we can see that on our Kibana, which is very useful because we know how many times this is 2 requests out of 100 every 15 seconds, and that's very useful for troubleshooting. Okay, so now we talk about bad actors, different kinds, the different kinds we have depending on the techniques, and now it's time to dive into specific abuse techniques and how we've set up mitigations at Harvest. So let's start with the basic, the very basic. So it's the general abuse, the well-intentioned users, the bad-intentioned users. Abuse isn't always target or malicious. Sometimes it's just too much traffic, can come from bots, API integrations that went rogue. If you leave endpoints unrestricted, that traffic can overload your system, slow things down, or generate noisy logs, and even cause full-blown outages, like I said before. So probably, like if you here we're all developers, so we probably integrated with third-party APIs. So we are very familiar with the term of rate limits. All APIs integrations, this is like the Stripe documentation. They even say that they rate limit API requests to help maximize the API stability, but it's not the only one. All of them, they have it. And of course, at Harvest, we also have it. We have even like a Harvest different limits based on the endpoint that we are hitting, because like, for example, the reports endpoint, in this case, it takes like more database resources, computation. So we want like to slow down a bit more that one, so like it doesn't overwhelm our application. So this is how we set up the limits, a simplified version. First of all, we have a throttle for like 100 requests every 15 seconds. And we, like, in order for us to like select the company or the account, it's per account and user, right? So we use information in the cookie. Well, not in the cookie because this is the API, sorry, it's for the web app. And in the authorization token, we use information that it's like common through all the requests to like differentiate the user, and then we return this discriminator. So this way we can like, just for every company and every user. But what about the reports API rule? So in this case, we have a different like rule for that it's like 100 requests every 15 minutes. And we added an extra condition from information that we can get from like the requests, which like this block will return false if we are not like hitting this endpoint. So in that case, it's a bit similar. So if like you're hitting this endpoint, we are going to use the same another discriminator. So I wanted to introduce this one. But what happens, so if we are setting general rules, what happens with like internal requests? Like it's common that like you have internal integrations that hit your API too. So for that, you can set like safe lists in rack attack that will say like, okay, for all internal requests, don't go through any throttling rules. So you are not throttling yourself, you give yourself a bit more margin. So that's great. We can also determine that from information in the request, like a header or like the token that we are using and so on. So let's go to another like kind of attack. So now we have credential stuffing. Credential stuffing, it's automated login attempts using leaked credit card details. No, leak user names and passwords. We'll go to the credit card later, sorry. It is one of the most common abuse patterns, and it targets your login endpoints. Even if your password is ultra secure, if you reuse it in every single service, you are exposed to leaks, and that data is available for everybody to check. This website tells you if your email has been in some of the public leaked, and like the list that returns, it lists companies like Trello, Twitter, Dropbox, LinkedIn. So you should trust nobody. Do not reuse your passwords. Credential stuffing can be the gateway to bigger attacks. If bad actors access your user accounts, their private data will be exposed. And it's our responsibility to protect users, not just ethically, but also because it can damage our reputation. And the rage will come towards us, even if it was not our fault, because it's like they should use a password manager. Even like if one attempt success, we have a problem. We need to kick on like additional like techniques to like reset the passwords, reach out to the user, and let them know what happened. So how we set up rules for that? So in this case, we have like a stronger limits on our login endpoints. So it's like limit of 10 requests every minute. We can now check like the path of the request and like the method too, if we want to discriminate faster, like because probably the like checking the path, if it starts with something, it's like a bit slower than just like the verb. And we block by IP. At that time, we don't have the user authenticated, so we need to block by IP. But what else? Like we also have a lot of alerts. So if we detect too many failed logins, we get an alert on Slack, and that will allow us to investigate further. And then set up additional mechanisms like CAPTCHA on Cloudflare, or start blocking IPs if we detect that they are coming from the same place. how we block IPs. Apart from blocking IPs from one of the layers, like we have a mechanism built in like our harvest admin, which is like a block list that will check if the request IP is banned, so we can quickly ban IPs without having to deploy the application, which is very useful. Okay, sign up spam. This, as I said, bots that register fake accounts. I don't know why they do it. I mean, like, why would you have a lot of accounts? Maybe they want to send a lot of spam, but sometimes they don't do anything with those. That's bad for your statistics, like trial to paid conversions and so on. It's always a mess when this happens. It overwhelms all our third-party integrations. Recently, we had like a problem with Psychic because there were too many jobs in there due to one of a situation like this. So how we prevent that? In this case, we have, again, more stricter throttling, so it's 10 requests every 24 hours, but we do like an additional check on, apart from checking the method, checking like the path, we have a check that is called looks spammy, that based on the patterns that we detected that like are coming from these like bots, or like spammers, we have additional checks, and we use the same discriminator. That means like if we detect like the request is coming in this form, we will discriminate everybody, not based on IP, because sometimes they come from different IPs too. So now I'm going to show you the look spammy. No, 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 but if you want to know, because I must say, like, these people, these are real people behind this. It's not a machine, because like sometimes they detect what we've done and they can work around that. So like we are always behind them, like, whoa, they notice what we are doing and now they are trying something different. So I'm not going to give any tips, but if you're like curious, I have a lot to say about this. So could we catch legit users? Yes, but this is for a greater good, and we have the login and for the troubleshooting and everything. And of course, we have alerts. So if we detect that there's been many accounts created in one day, then we can jump into the logs, we can see what happened, we can see if it was legit or not, and then we can quickly set up extra protection, block IPs, clean up all the data so it doesn't affect our statistics. Okay. Business logic abuse. Now we are getting into the fun stuff, because abuse, this is the abuse that it's unique to your app, depends on the features that you provide, and all kinds of like bad actors use it. Like, as I said, what they like about us, well, one thing. So here is when you will understand what I said before, that you cannot intercept all these scammy like requests from the other layers, because here is like when the mechanisms are like a bit more sophisticated for us to not log in like legit users. And we need like to get access to the business logic that we have in the Rails app. So, of course, in our Harvest, we allowed sending invoices or estimates via form, and you can just add like an email address in there. And this is one of the most exploited endpoints that we have, and people use it for things like this, like sending, because at some point we allowed images on the email. Don't do that. We removed that. That's not, but that's a screenshot that, like from a past spammer attack. And, or things like this, you know, they impersonate trusted parties, PayPal a lot, or like Geek Squad too, they do it a lot. And they like prompt people like, oh, you can call us to get more assistance. No, like if they send like 1 million emails, maybe one person will call, right? So because there are so many ways and so many patterns that we detected, we could abstract this in our way, in a way that we cannot just have to create like individual rules, like we have a mechanism. And so we loop through throttling rules. I'll show you a rule later. We set up like a rule, like it's the name, the limit, the period. One interesting thing about rack attack is that the limit can be a proc and the period too. So you can set up different limits based on whether the user is authenticated or based in other like checks on your database, right? Which is very interesting. So you don't have to create different rules for that. Then we retrieve the rule, we run the conditions, which is like the checks, like request, post, whatever, and then we get the discriminator for that rule. So this is one of our rules. This is for creating invoices, not through the API, but through the website. It's 100 requests every 20 hours. The throttle discrimination is the subdomain, which means it's like the account ID, the company ID in this case, method post, the path that we are matching, the API check, it's not the API, so we can return quickly, and then we have an extra check. This is like an extra condition that tends to be a bit more expensive. It's a condition that checks the database too. We need to perform this check in all, every time that somebody submits an invoice, which makes the request a bit slower. So we have to be very careful to not introduce a performance regression here. And in this case, we detected new non-paying companies, they were most likely going to use this endpoint, so we set up restrictive rules for them. And if there is a scammer watching, if you create a paid account, we have rules for that too, so don't do it. What more? Okay, this is also very interesting. Everything is interesting, so I had to put everything on the slides. This is another thing that Rack Attack has that we use together with these rules. So we can subscribe via the active support notifications API to whether there's been an endpoint throttled. And then based on the annotated data on the request, we can somehow make some changes on the names, whatever. We can retrieve the rule that triggered that throttling. And then we can mark all the discriminators in the database as suspicious, we call them, right? It's oh, this person has been, this thing has been throttled, or whatever that is. So we will mark that company as suspicious. So we go back to what we've seen before on the limit here, right? So based on that suspiciousness level that we called, we will even slower them more. This is automatic, so we buy us more time if we detect some sketchy behavior. Sometimes this catches a lot of legit users. There are people that might have a lot of clients and they send a lot of invoices. But sorry, and then we can just safe list them. That's great. Or if it's malicious, we also call them, we can effectively block all of the endpoints that are more obvious that we have, which it's different as blocking the IP because they will not be able to use some part of our application, but the rest of the application is kind of they can still browse it. So they can reach out to us and ask what happened. And of course, we have alerts for that. We have alerts, so oops, yeah. So we have alerts when a company has been flagged as suspicious and why, the rule, or if we did it manually. And we have alerts every time we detect any suspicious activity. So that's when the security team, comes in, investigates, and we can create extra rules, remove rules, start blocking IPs again. Last but almost finished. If your passwords are not secured, your credit card details are not secured either. So be careful with that. So fraudsters, they love SaaS applications with a payment flow to test credit card details. And of course, we also handle this by adding throttling rules, for the subscription updates and so on. But we also, I wanted to show this because I've been working on the billing at Harvest for 3 years now, and it's very close to my heart. And I wanted to show you how we utilize other tools to go full circle with what we have built. So in this case, we are listening. If you're familiar with Stripe, you can listen to events via a webhooks call, and then we get the charge, and based on the risk score by Stripe Radar, that it's flagging some charges as risk score of 40 or 50, we can take that and mark the company, the Harvest company, as malicious, or set it up for manual, if the payment has been set up for manual review on the Stripe Radar rules, we will mark it as suspicious. So if most likely if they are scammers, people trying leak credit card details, they are most likely going to try to use that to use the invoice endpoints and sending endpoints, so we can block them with other tools, which is great. Last but not least, this is the very last, distributed denial of service. DDoS attacks aren't subtle, and you quickly realize something is going on. They want to knock your site down, flooding it with traffic. And rack attack can help you a bit, but it's not anymore our main line of defense. We had to set up Cloudflare last year. I think other companies were in the same situation. But having Rails level protection still matters. Maybe if your application is being hit by a low scale, a smaller scale DDoS scenario, you will be able to support it with blocking rules or something like that. But if the attack comes from multiple IPs or uses more sophisticated techniques, there is only so much we can do without a full-blown web application firewall or a load balancer that can stop requests before they hit the rack server. And maybe you will find yourself in this situation. I don't work for Cloudflare, but I like this button that they have here. So you know it's very quick to set up. So thank you so much. I made it on time. And if you have any questions, you can come find me.